Hello everybody, welcome to this computer graphic lecture series. So in this lecture series we'll be doing everything that has to do with computer graphics. And when we talk about computer graphics, we talk about everything that you see on the screen, be it your phone, be it your computer, be it the power of your camera, everything that has to do with display, visual, it has to do with computer graphics. So if you have any interest in such topic, or if you want to get into a career that does with computer graphics, let's say animations, things of that sort, then this is the right tutorial. Stick along to the end. So computer graphics, it literally involves, like I said earlier, the display, the manipulation and storage of pictures and experimental data for proper visualization using a computer. So a computer is anything, even your smartphone is a computer. It's just something that can process. It has processing power. Okay, so computer graphics literally, as per definition, is the creation of pictures with the help of a computer, a processor. Okay, so the end product of the computer graphics is a picture. Okay, is a picture, be it a static picture or a moving picture like a video. All that is the end product of computer graphics. Okay, so it may be a business graph, drawing, or engineering, simulation, anything. Okay, so the main thing to grasp is computer graphics literally is just the creation of pictures with the help of a computer. Okay, so it's computer graphics, creation of pictures. Okay, so in computer graphics, 2 or 3 dimension pictures can be created. With 2 dimension pictures, like stick pictures, you've seen those. Like you can, like if you draw something on a paper, that's like a 2-dimensional picture. But if you draw something, let's say use applications like Blender for example, you have something that has both the X, Y and the Z axis. So it has 3 dimensions, it becomes 3 dimension. If it has only X and Y like what you draw on the paper, it is 2-dimensional. All those can be done using computer graphics. So many other devices, algorithms are being developed for improving the speed of picture generation with the passing of time. So softwares like Blender, Adobe, all of them are being introduced in order to create pictures, yes, but with much more efficiency and speed and clarity. Okay, so types of computer graphics. So we have generative graphics. So this is used to create lines, circles, ellipse. So we have also image analysis, which is used to generate images, pictures. Then we have log native. Okay, so this is used for photographic images, like when you take photo of someone, that's log native. Okay, and with image analysis you just generate pictures and images. Okay, so so why do we use computer graphics? Well, the need for it is very much evident to all of us who have modern devices, computers, phones, literally. That way you interact with your phone through the screen is literally everything. Okay, but suppose a shoe manufacturing company wants to show the sale of a shoes for 5 years. For this amount of information to be stored, so a lot of time and memory will be needed. Okay, so this method will be tough to understand. So in this case, a graph is better alternative. So this is actually evident. You have loads of textual data and you have graphical data representing the textual data. The graphical data is normally easy to interact with and easier to understand, even for non-technical people. Okay, so it has a huge advantage when we come to dealing with huge data set, when you come to dealing with large information. Okay, like right here we're talking about sell for shoes for 5 years. It's a very long time because we're talking about daily sales. So with a graph, it's easy to understand when the sales plummeted or when the sales rose to the skies. Okay, so typical graphics system. So the graphical system comprises of a host computer which with support of a fast processor. Fast processor is really everything. large memory, frame, and frame buffer. Okay, so it has to have a fast processor, it has to have large memory for storage, and it has to have frame buffer. Okay, and display devices. It should have a display device like the monitor that can support colors. It has to have input devices. Okay, let's say you have mouse, for example, a keyboard, maybe a joystick, a touch screen, a trackball. Okay, and it has to have output device. Let's say LCD panels, laser printers, color printers, plotters. Okay, interfacing devices such as video, IoT, input output, TV interfaces. So all these typical graphical systems components. Okay, so these are what may comprise a graphics system. Okay, so the conceptual framework of interactive graphics. Okay, so we have the application model, then we have the application program, then we have the graphics system. Okay, so what happens here is that the application program interacts with the graphics system, and the graphics system interacts with the output and the input. Okay, so all in is interpreted by the program, then the input or output is passed through the graphics system. Okay, so this is the conceptual framework of an interactive graphics system. So the applications of computer graphics. So with this, it will be very much easy because these are things that we are literally doing every day. So the first one is education and training. So computer generated model of the physical, say maybe financial, economic system is often used as educational aids. Okay, so we normally see this in subjects like geography, for example, where the financial, maybe physical data, they are modeled by a computer, then we use them for educational purposes. Model of a physical system, physiological system, population trends, or equipment can help trainees to understand the operation of the system. So something visual is, like we said earlier, is easy to understand. So it's used in education and training to simplify the process. So for some training applications, particular systems are designed. For example, we have flight simulators. So with flight simulators, they're used to train pilots of airplanes. Okay, so they stay in a cabinet that is supposed to simulate a real aircraft and real aircraft conditions. Okay, so with this, fuel is saved, there is safety, because sometimes maybe due to training conditions, the pilot may crash the simulator, but there is absolutely 100% safety, because if he were in a real aircraft, maybe he would have died or something like that when they are simulating stalls, for example. So having a simulator really saves lives apart from fuel. So ability to familiarize with the training with a large number of world airport, because with the simulator we have lots of airports, lots of aircrafts, models that are often used. So pilots can train with numerous number of aircraft, with a numerous number of world airports with different conditions. So we create competent individuals with little training cost. Okay, so that is truly an advantage. Okay, so using biology, so molecular biologists can display a picture of a molecule and gain insight into their structure and help with the help of computer graphics. We've seen this. Okay, we know how bacteria look like, we know how the cells look like, we know the things that are composing of a cell, we know how the cell wall behaves, everything that has to do with molecular biology. They're simulated. Them being simulated makes it easier for learners to grasp. So in biology, this is actually very, very important. Computer generated maps. Okay, so we have town planners and transportation engineers can use generated maps which display data useful to them in planning their work. So a great evidence of this is the Google Maps. So with Google Maps, you have the entire map carefully and accurately plotted. So with that, town planners and transport engineers can plan with much more ease. So number 4, architect. Okay, so computer graphics is also applied in architect. So architect, someone who designs. Okay, I say designs a house before doing the actual building of a house. A design is made. There are tons of software for doing architecture design. So only through computer graphics is architecture design using a sophisticated system like computer system an option. So they can literally just design everything and with high accuracy, the way it will look and stuff like that, after which then the construction is done. So with computer graphics, it gives us this opportunity in architect. Presentation graphics. So this is probably something that most people have already seen: bar charts, line graphs, pie charts. So this normally used to present data, say present financial reports, statistical reports, scientific reports, you name it. Okay, so with presentation graphics, it actually makes easy to understand data, and more so data dealing with multiple parameters. It's easy to understand the relationship between two parameters or more than two parameters due to computer graphics. Okay, then we have computer art. So computer graphics are also used in the field of commercial arts, used to generate television and advertising commercials. This is probably done by softwares like Blender. You've seen Blender making commercial advertisements. You have Adobe, a family of software. So all of them are an application of computer graphics. Entertainment, this is something maybe the most popular application of computer graphics, whereby they are used in making motion pictures like movies, music, television shows, and the rest from entertainment. Visualization. So it's used for visualizing, scientists, engineers, medical personnel, they use computer graphics to study large amount of information by visualizing it and trying to get something from it. Like data scientists, for example, they collect so much data and then they just visualize it using graphs, for example, pie charts, so that they can get some useful information out of them. We have educational software. So computer graphics used in development of education software for making computer aided instructions. And lastly, printing technology. So this is something that is also very popular. So you can literally transform whatever you have in the computer into an actual tangible object using, say, a printer. Okay, so this is also an application of computer graphics, also been done using computer graphics. So example of computer graphics packages have Logo, CorelDRAW, AutoCAD, 3D Studio, Code, GKS, and the rest as you can see mentioned down there. So with this, we'll just dive into a few, but these are very common graphic packages. We won't be going through all of them, but in the later parts of the tutorial we will do some of them, not all of them. but it's just good to be aware of what's actually available. This is just some of the many available graphics packages. Okay, so passive computer graphics. So in passive computer graphics, the picture is not produced on the monitor, and the user does not have any control over the image. In fact, the user cannot make any change in the rendered image. And one example of this is the TV shows, some music videos, anything that the user does not have any control over. That's something we call passive computer graphics. So passive graphics normally involve only one-way communication between the computer and the user. User can see the produced image but cannot make any changes whatsoever. And then we have active computer graphics. So user have some control over the image. So the user can make any change in the produced image. For example, let's say a game, like let's say a football game on your phone. You actually have control over the graphics of what the phone should show, where the player should be positioned. So that's active computer graphics. So it just requires two-way communication between the computer and the user. So it's, in other words, interactive. So user can see the image and make any changes by sending its commands with an input device. So we've talked about the components of a graphics system. So that's that will come in handy. Okay, so advantages. So advantages of active computer graphics. So there's high quality, more precise results and products, greater productivity, lower analysis and design cost, significance, enhance the ability to understand data and perceive trends. Okay, so those are the advantages and many more. Okay, so working of an active computer graphics. So the modern graphics display is very simple in construction. Okay, so it majorly consists of three components, and this is the active computer graphics, the one that you can interact with. Okay, so we have the frame buffer or the digital memory. So the frame buffer is one of the three components of an active computer graphics system. We have a monitor. Okay, a monitor like say TV, for example. Yeah, and then we have the display controller or video controller, which passes contents of the frame buffer to the monitor. Okay, so this is the main three components. Okay, so the frame buffer, the digital memory, it stores the information, say commands from the display controller, and then we have the monitor that receives instruction from the buffer, the digital memory, then displays them to the user. Then we have the display controller or video controller, which is actually a sort of input. Okay, that takes an user input that will later be displayed on the monitor. Okay, so working of an active computer graphics. So like I said, we have the frame buffer or the digital memory, then it's being sent into a register, then into a DAC, then electron gun. We will talk about electron gun in the later tutorials. But a single bit plane, this is the single bit plane, which is black and white frame buffer raster CRT graphics device. Okay, so we'll talk more on the raster and the electron gun in the coming lecture. Okay, but this is just a simple illustration of how active computer graphics actually works. So a frame buffer is a digital frame. So is a large contiguous piece of computer memory used to hold or map the image being displayed on the screen. Okay, so it's literally just a memory. So anything that's a buffer, it's a memory. It's a digital memory, It is large and contiguous, so and it's used to hold or map the image displayed on the screen. At a minimum, there is one memory bit for each pixel. That's at minimum. I have one image bit for each pixel. Okay, so this amount of memory is called bit plane. So the minimum memory is called the bit plane. So a 1024 times 224 element requires that much square raster in a single bit plane. So if you have an element, let's say you have an image element that's of those dimensions, 1024 times 224 dimensions, it will require that much square raster or that much memory bits in a single bit plane. Next, we have the picture is built upon the frame buffer 1 bit at a time. So it's one bit at a time, but due to the fast processor, which is a requirement for a computer graphics system, this process is normally very fast, okay, because a memory bit has only two states, either 0 or 1. A single bit plane yields black and white, that's which is a monochrome display. So as frame buffer is a digital device which writes raster CRT, is an analog device. Okay, so properties of video monitor. So we have persistence. So persistence is the duration of phosphorescence. Okay, persistence is the duration of phosphorescence. So different kind of phosphors are available for use in CRT. Besides color, a major difference between phosphor in their persistence is in their persistence how they continue to emit light after the electron beam is removed. That's the persistence, how it persists. Okay, so duration of phosphorescence. When the electron beam is already has already passed, or has already been removed, the duration, I mean how long does the phosphorescence last, how long does the colors persist, that's the persistence, and it's one of the properties of a video monitor. The second is resolution. So resolution is just used to describe the number of pixels that are used to display an image. Okay, so the number of pixels that you use to display an image is normally termed as resolution in this the second property of video monitor. The third is the aspect ratio. So this refers to the ratio of width to height. It's a measure in unit in length or number of pixels. Okay, so you can see the aspect ratio right there. Its formula is width unit over height unit. Normally the width is longer than the height, except in square monitors. And that does it for today's lecture. If there's any place that you want me to elaborate further, you can leave there, you can ask about it in the comment section below. But until next time, stay safe. Don't forget to subscribe, like the video, share it to friends and family who will be interested in computer graphics, and stay tuned for the next videos that I'll upload in this playlist.